Hi everyone, welcome back to my channel. So in our last video, we have discussed about the challenges which the traditional network is facing while deploying the network devices into the network, and some management challenges also we have discussed about that. Okay, so the challenges were first one, the deployment, then uh, management challenges. Okay, then we have discussed about the security issues which traditional network can face. Okay, and then we have discussed about um, the tunnel concept. Okay, we have discussed about GRE and IPsec. Okay, so now today in today's video we're gonna discuss about um, control plane and data plane. So why we need to discuss about this concept here is because in traditional network the control plane and data plane both are on single router. But in SD-WAN we can separate the control plane and we can separate the data plane. Okay, so let's discuss about this concept first. So here I have a small diagram here. um, Here I this one is a this is a router. Okay, so this is a router. So on this one, the first part of it is route processor, and the second one is a routing table. Okay, this one is R1 and this one is R2. Okay, and we are running a protocol called OSPF between this one. So the function of this route processor is to process the information to form the routing table. Okay, so processing an information like in OSPF, it can process the LSA information. So LSA is link state advertisement. So LSA information is shared between R1 and R2 so that it can process the routes, okay, to form the routing table. Okay, after this route processor process the information, the responsibility of the routing table is that whatever it receive a packet, if there is a route entry for it, it will directly process the packet and send out to a particular outgoing interface. Okay, so whatever the packet processed by the route processor, it will send that packet to the routing table. A routing table will make an entry for that particular packet or the route, okay, in its routing table. Okay, and after that entry has been made on the routing table, it will see to which interface this route is supposed to send. Okay, and it will send the route to that particular interface, like on this one 0 by 1, or we have or 0 by 0. Okay, so it will see the entry of the routing table. Okay, and will process and pass on the route to that particular exit interface. So this route processor is the control plane on this router. Okay, and this routing table is the data plane. So there is route processor which is called the control plane, and routing table which is called the data plane deals with the so this deals with the control information, means it deals with processing the information. Okay, and data plane deals with the actual forwarding of the packets, or forwarding of packet, or you can say forwarding of data. So this control plane and data plane, so this control plane and this data plane both are within the router. So most of the processing power of the router is used in processing the information, the routing information. Okay, so the question comes here is, as this router has both control plane and data plane within it, can we separate control plane and data plane? Yes, yes, we can separate control plane, data plane, and that we're gonna see in SD-WAN. Okay, and that we're gonna discuss later in this series. Okay, how we're gonna separate the control and data plane. So in SD-WAN, we will move this control plane to somewhere which is powerful enough, right, to process all the information. So the advantage is that it is easier to manage multiple routers. Okay, so in traditional network on single router we have control plane and data plane. So most of the control plane of a router is used in processing the information on the router. So it means all the processing power of this router will be used in processing the information. Okay, so moving the control plane to a location which is powerful enough to process the information, and it is easier to manage and process the information also. Okay, it is easier to manage the routers and to process the information. So moving the control plane in SD-WAN to a centralized location so that it will be powerful enough to manage multiple routers, so powerful enough to process the information of multiple requests. Okay, and this power of processing the information through a centralized control plane is called the centralized policy, which is used in SD-WAN. So like in SD-WAN, this control plane and data plane, so both can be connected through either through a physical cable, or we can form a tunnel between the centralized control plane and the data plane. Okay, or this tunnel means will form through a virtual link between control and data plane. And having a centralized control plane means it is easier to manage a single control plane, or if we have means one or two control planes to process multiple requests from the multiple devices. It is easier to manage those two or three control planes than multiple routers running a control plane. Okay, so let's suppose if we have 1,000 routers, So it is difficult to manage the control plane information on these 1,000 routers than to have three centralized control plane. Okay, and this centralized control plane concept we're going to use in SD-WAN. Okay. Okay, now we have another topology. Okay, now we have another topology. So in this topology, we have three routers, R1, R2, and R3. Okay, so all three are connected to a service provider network. Okay, and so this service provider network have multiple routers in it. Okay. Okay, so in this, we're gonna learn about a concept of hub and spoke. Okay, so this hub and spoke concept is used wherein we can set up a data center which we will set up as a hub, and this branch sites will be set as a spoke. Okay, so in most of the company's policy, you can means we can run a routing protocol only between branch sites and the hub sites. Okay, so the routing protocol will run between uh, the spoke and the hub. Okay, okay, so here we can see between R1 and R2. Okay, both are on different subnets. Okay, we cannot run a routing protocol. So to run a routing protocol, suppose between R1 and R2, like we are going to run an OSPF, so it should be on same network 1.1 slash 24 1.1.1.2 slash 24. Okay, so to run a routing protocol between branch and spoke sites, we gonna we're gonna create a tunnel between R1 and R2, and same goes with R1 and R3. So here R1 will be means here R1 is acting as a hub. Okay, and this one R2 and R3 will be acting as a spoke sites. Okay, and we will run OSPF between these two tunnels. And the company policy says we cannot form a tunnel between R2 and R3. Okay, so we cannot form a tunnel between R2 and R3. So let me tell you about the traffic pattern. So the traffic pattern between R2 and R3 will be formed from R2 spoke site. It will go to R1. Okay, and then from R1 it will go to R3. Okay, so there will not be any direct tunnel between R2 and R3. But in SD-WAN, R2 can directly reach to R3. Okay, so SD-WAN has a capability through OMP. OMP is Overlay Management Protocol. So this protocol is used in SD-WAN. Okay, so basically um, it's a concept related to SD-WAN. I'll go ahead and explain the things later on in the video also. Okay, but just think about a protocol which is used in SD-WAN so that the spoke sites can directly communicate. Okay, so in this one, in traditional network, if R2 wants to communicate through R3, R2 will reach out to the hub site. The hub will check its routing table. It does have the routes to reach the R3. It will go ahead and connect with R3 directly. But in SD-WAN, the R2, the R1, okay, so, but in SD-WAN, the R1 will share the R3 spoke router information, or R1 has the next hop information of R3, which is 3.3.3. Okay, R1 will share this information with R2. Okay, once R2 has the information of the next hop, once R2 has the information of the next hop to reach R3, it will directly communicate with R3 instead of going control plane, share the information with the edge devices. Okay, when once the edge devices does have the information, it would directly form a tunnel, which will be the which will be IPsec tunnel. So these R2 and R3 will share an IPsec tunnel between them, okay, to share the data between them without reaching the hub site or without reaching a data center to share the information. Okay. So now the traffic will flow via directly service provider. Okay, so there is no reachability, means it will not pass on the traffic through the hub router. No traffic will go to a hub router. It will directly traffic will flow via service provider and will form a tunnel, which will be the IPsec tunnel. And this IPsec tunnel, which will be formed, that will be the data plane between the routers or between the spoke sites. So here, if the service provider network provide a connectivity between 1.1.1.1 and 2.2.2.2, okay, then we will be able to form a tunnel between R2 and R1. Okay, and this tunnel which will be formed, that will be the overlay network. Okay, and this overlay network can run routing protocols on it. So that means we can run the routing protocol over the tunnel. And the tunnel which will be formed between R2 and R1, or we can say between R1 and R3. Okay, so that will be, these tunnels will be a virtual tunnels, or you can say or virtual link. So the IP addresses on the tunnel, okay, so the IP address on the tunnel can be on the same subnet. The reason is because there are direct connectivity on this virtual link, which will be a tunnel. So if I'm planning to run a protocol like OSPF, BGP, or EIGRP over the network between R1 and R2 or R1 and R3, okay. So this so over the tunnel we will run a same subnet. Like in I can run 192.168.1.1/24 and 192.168.1.3/24. Same goes here with 192.168.1.2/24. Okay. So over this tunnel, we will be running a same subnets, okay? But on the physical connectivity between R1 and R2 through a service provider, the subnets are different, okay? And on this tunnel, we can run the protocol, okay? So, so let's suppose if R1 wants to reach x dot x dot x dot subnet, it can reach via 192.168.1.2, which will be the next job of the R1 to reach the particular network. Same goes for, let me clear this one. So same if R2 wants to reach z.z.z.z network, it can reach through 192.168.1.1/24, and this the tunnel will be formed between these, and these tunnels we say overlay. These are overlay tunnels, overlay network. Okay, it's 1.1, 1.2, sorry, 1.2, 1.3. So these are 192.168. Okay, so similarly, R3 will run z.z.z.z route via 192.168.1.1 network. Similarly, R1 can reach y.y.y.y network through 192.168.1.3 network. Okay, so let's suppose if this R1 wants to communicate with R3, okay, and if wants to reach, if a laptop, let's suppose if we have a laptop having the IP z.z.z.z wants to reach another laptop which is behind this R3 having IP y.y.y.y, and the IP packet will be like z.z.z.z with the source IP towards destination y.y.y.y. It will be encapsulated with GRE header, okay, and now this IP packet will be encapsulated with another IP packet whose source IP will be 1.1.1.1 and the destination IP will be 3.3.3.3. And once R2, I'm sorry, once R3 will receive this packet, it will be decapsulated by R3 and will check and send the packet. Will check the packet and will send the packet to y.y.y.y. And as we know, this GRE is not secure. And to make it secure or to secure the packet which will be sent over the tunnel, we'll use IPsec, IP security. Okay, so this packet, on this packet, we will add one more header, and that header will be IPsec header to secure this packet over the tunnel. So this concept of forming a tunnel and encrypting a packet, the same thing will be doing in SD-WAN also. Okay, so SD-WAN is also building an IPsec tunnel and then send the traffic over this IPsec tunnel. Let's discuss about a concept of tunnel. So there are two types of tunnels. One is point to point tunnel. The second is point to multi-point. Okay. So this point to point tunnel, there need to be a point to point tunnel which needs to be formed between hub router and the spoke routers. Okay, and this tunnel will be formed between them. So this will be a point to point tunnel. And let's suppose if we have multiple routers. So let's suppose if we have multiple routers, like we have R4, R5, R6, R7, or like in we have, let's suppose we have 100 routers. So creating a point-to-point tunnel between 100 routers, which will be acting as the spoke routers, and with the data center, and which will be acting as a hub router, will put high load on this router. Okay, so it will be a single point of failure. Okay, to solve this issue, what we are going to do, we're going to create point to multi-point tunnels between hub and spoke routers. So the tunnels will be point to multi-point. Okay, so this particular point, it will form a tunnels with every router instead of forming a tunnel with a single router. Okay, so from hub router, they will initiate to point to multi-point tunnels to multiple spoke routers, and we can run a routing protocol like OSPF over these tunnels, and it can form direct connectivity between R1 and R2, R1 and R3, or we have if we have any other routers. And this R1 will change the next hop. Okay, so if R2 wants to communicate to R3, okay, the next hop to reach R3 will be the hub router, okay, and R1 will change the next hop to R3 IP address. So it can directly form a tunnel between them. So in SD-WAN, how we're going to change the concept of traditional network, of the control plane, of the overlay network, of the underlay network, okay? So in SD-WAN will form a centralized smart device, which we call as vSmart, okay? And all the control tunnels will be formed between the smart device and the device or the branch routers, okay? So the branch So branch 1 will share the information with the smart device. Smart device will process the information and will pass on the information to every every router in a site. Okay. So instead of having multiple routers with a control plane, there will be a single control plane here in SD-WAN. Okay, and then after receiving the information from the control plane or the smart device, the branch router will process it and will accordingly form a tunnel, which will be a data tunnel, or we can say it will form an IPsec tunnel between them. Okay, so the branch routers will form an IPsec tunnels between them after it will receive the information through means from a smart device. Okay, so once the branch, let's take an example of branch one. Okay, once the branch one receive the information, means it will form a control tunnel, and this control tunnel will be TLS or DTLS. It is called the transport layer security or data transport layer security, you can say. Example of this branch one. So branch one will receive the information like if it's want if branch one want to reach c.c.c slash 24 network, it's need to reach to data center. Okay, same goes if branch one wants to communicate to b.b.b.b slash 24 subnet, it needs to go to branch 2. Okay, so these kind of information it will receive from the control device. So once the branch 1 has all the information to route the traffic towards 2.2.2.2, okay, and all this information which branch 1 has, it will receive this information from the smart device, which is a centralized device. Okay, and once it has all the information required from the control plane, which will be a smart device, I just need to send the data through a tunnel, and this data tunnel will be formed between the branch devices. So one thing you need to keep in mind, the tunnel which will be formed between branch 1 and branch 2, this data tunnel will be formed automatically. Okay, once branch routers will receive the control information from a smart device, once it receive the information to process the routes or to process the traffic, it will directly form a tunnel between the branch routers. Okay, and this tunnel will be formed automatically, and then it will process the packets or it will transfer the data between the branch routers directly. So I think we are good on this video, and we'll proceed with another video where we will learn the other concept of SD-WAN. So in another video, we will discuss all the components of the SD-WAN and how the components will work, what are the function of each component, and how each component will help us to share the routing information between the devices. If you like this video, please hit the like button and subscribe to my channel for more videos like this. I'm planning to share multiple videos on this series of SD-WAN where we'll learn everything about the SD-WAN, the requirement, the devices, the function of devices or within the SD-WAN, the control devices, the devices, how the traffic will flow in SD-WAN. Thank you for watching this video. Have a wonderful day. Peace.